All right, guys. So as we were saying, to look at decimals in terms of a fraction, we need to understand something about our place values in our numbers. Now, if you look at the word 666, and you look at it in terms of place value, we know that the extreme 6 to the left would mean 600. Now, 600 would be the place, the 100 would be the place value where the 6 is. Now, where you have this middle 6 here, the place value of that would be the tenths. So we would have 60. 60 would be in the tens column. Now, the 6 at the front here would be the ones. So 666 just simply mean that you're adding 600 plus 60 plus 6, right? Now, if we to follow that trend or that pattern, right, we would notice as well, as we said, decimal fractions are fractions with denominators of the base 10 raised to some power. Now, looking at this example now, as opposed to the one that we just saw, what we notice about these numbers, in the decimal number, these numbers come what? They come after the what? They come after the point.
Decimal.
And we call that point the decimal point. Now, for decimals, we take the point to separate the whole number part from the fractional part. So whatever number comes before the point, in this case 0, will tell you what whole number you have. Now, any number that comes after the point will give you an idea of the fraction of the decimal that you have. How does this work? Now, it works by looking at the first digit that comes after the point. It would be over 10, right? The second one would be over 100. And the third one would be over 1,000. Now, if you pay special attention to the zeros in the denominator, you'd realize that there's a little pattern here with these zeros and the decimal places. What do you notice about the decimal places and the zeros? Australia, do you see any pattern with the decimal places or point, the positions with the number of zeros?
Sir, they increase by 1.
They increase by 1. Now, how do they relate to the numbers that come after the points? The numbers that come after the point, how do zeros relate to that?
Sir, does it tell the amount?
Okay, Ms. Cummins, what are you saying?
So I think the amount of numbers determine the amount of space after the point.
The amount of numbers determine the amount of place.
The amount of zeros determine the amount of space that the number take up after the point. Like 3 take up 1 place after the point, so you have 1 0. The 0 is 2, so you have 2 0, and the 5 is 3, so you have 3 0.
All right. Is there anybody else who is in agreement with Ms. Cummins? Raise your hand. Okay. Yes, and that's so correct, because what you notice here is that these number that comes after the point help to determine how many zeros going to be below in the powers of 10. So if you have one digit after the point, then here we have 1 0 in the powers of 10. And so the first digit that come after the point is going to take 1 0. If you have two digits coming after the point, that means the second digit going to have a power of 10 square, meaning that you're going to have 2 zeros. So 2 digits after the point here, we have 2 zeros. We have 3 digits after the point, then that third number going to have 3 zeros down here. So that is something that you should observe, right? Because that is characteristics of the decimal system. Now remember, we say that these now represent the fractional part of the decimal. Now, if you look at them in terms of powers of 10, you see that 3 over 10 is 10 to the power 1, 3 over 10 to the power 1, 0 over 100, 10 to the power 2, 5 over 1,000, 10 to the power 3. So you can basically look at the powers to tell what decimal places these numbers have, right? So because it is over 10 to the power 1, then it has 1 decimal place. Over 10 to the power 2, then 0 is 2 decimal places. 10 to the power 3, then the 5 would be 3 decimal places. All right, so consider this number too as well. Now, this number has to do with whole numbers, right? Now, for this number, just like the one that we looked at first, the numbers in their place values, the first number would be in the ones column. The second number would be in the, so this 4 is in the ones column, so we have 4 times 1. This 3 would be in the tens column, so we have 3 times 10. The 2 would be in the 100 column, so we have 2 times 100. Now, when you actually carry out these multiplication, 2 times 100 give you 200, plus 3 times 10 give you 10, plus 4 times 1 give you 4. So you're adding actually 200 plus 30 plus 4. Now, if you look at them in terms of power, you will see that this is 10 to the power 2, 10 to the power 1, and 10 to the power 0. So for whole numbers, your place values are also in powers of tens. All right, consider the decimal fraction now. Consider the fractional part of the decimal, which is the part that comes after the point. Now, see where we have the powers of 10 here. Now, if we are to convert this number now, let's say that we want to write this in a fractional form, then what we need to know is that the number that comes before the point would be the whole number. All right? So this number is a decimal fraction. Now it has 2 parts. It has a whole number part, which is 4. It has a decimal fraction part, which is 0.67. Now, if you are to say convert this into a regular fraction, what would you do? Let me clear these and use somewhat an easier number to calculate. Suppose we have 2.75 and we want to convert this. We want to convert this into a regular fraction. What can we do to convert this into a regular fraction? knowing what we have learned just now, how could we convert this into a regular fraction, students?
Sir, the 75 behind the point would have represent the power is the power of 100. So in order to change this now to a fraction, we would have jumped 2 spaces to the right. So you'd get 275 over 100.
All right, now, remember now, the numbers that come after the point would give you the fractional part.
Yes.
That these numbers would have to be the numerators over some powers of 10. Not 2, because the 2 is the whole number part.
Right.
So what we would do, we'd write back the 2 as the whole number, and then we write these now over some powers of 10. So you, as you rightfully say, we have 2 digits after the points. And so these 2 digits would tell us what power of 10 we have in the denominator. And so if you have 2 digits, how many zeros you're going to have in the powers of 10 in the denominator?
2.
2. So therefore this become what? 2 and 75 over what?
100.
Over 100.
Why, sir, me never learn nothing like this.
So 275 over 100. All right, now we can now easily simplify this fraction into its simplest term, because we can now find the highest common factor for 75 and 100. So we want the highest number that can go into 75 and 100. What would that be?
5, sir.
25.
Sure,
Oh, 25. True.
right. So the highest common factor for the numerator and the denominator is 25. So we're going to cancel by 25. So 25 into 75 give you what?
3, sir.
3.
3.
25 into 100 give you what?
4.
4. All right. Give me a second, guys. Let me take an incoming.
Oi.
No. We said man that wicked, you know? Said man
Yo, God. Someone shoot
that
them
man
up.
have you like a clone. Imagine, come me. But so we teach you a 2.75, you know. We just move it to a space and I get 275 or 100, you know?
No, never. I said just relax.
Oh, easy, no, man.
I am teaching.
All right, guys, just give me a second to sort something out. I'll be back shortly. All right, guys, sorry about that. I'm just trying to help out some students to get into the Zoom space. All right, so as you were saying, Ms. Waysome, so we would have canceled 75 and 100. We would use the highest common factor, which is 25. 25 into 75 is 3. 25 into 100 goes 4. So we'd write this back as 2 and 3 over 4. So now that would give you a regular fraction. All right, sorry about that, guys. Good evening to those who are just coming into the group. All right, so we have another new member just joined us, and hopefully we'll have another one soon. All right, so as I was saying, to convert a decimal into a fraction, we know that the number that comes before the decimal point, you would have that as a whole number part. And the numbers that come after the point, those will be the fractional parts. But because they are decimal, they are over powers of 10. So the first digit is over powers of 10. In other words, 10 to the power 1. That means you have 1 0. The 5 would be over 10 to the power 2. That means you have 0. So in other words, you would have 75 if you group these two together over 100, right? So if you count the number of digits after the point, it gives you an idea. It tells you how many zeros that you're going to have down below in the power of 10. So 2 digits after the point, 2 zeros in the power of 10 of the fraction. So now we write 75 over 100. And so this fraction that we have now written can be canceled using the highest number that can go into 75 and 100. So the highest number that can divide 75 is 25. So we use that to divide 75 and 100. So 25 into 75 goes 3 times. 25 into 100 goes 4 times. So the fraction becomes 2 and 3 quarters. Is everybody following so far? Raise your hand if you understand how that works. All right. Now, for the persons who have just joining, you can just bear a little bit because the classes that we have, the class sessions, they are on videos. So we'll be uploading them so that you can review the session at your own leisure. All right, guys? So if you are not following so clearly right now, you should try to go back over the videos. All right? All right, so when we look at this number 4.67, we see that has 2 parts, the whole number part, the decimal part, and that would give you the fractional part of the decimal, right? Now, the whole number part and the fractional parts are separated by a point known as the decimal point. Now, example here, we have 4.305. Now, we would know that when there is no whole number, this is something that you should make a note of. If there's no whole number, then the whole number position is, we insert a 0 to take the whole number position. So here, if we didn't have a 4 here, then we would put a 0. All right? All right, so with that said, it means that 0.305 would not have a whole number part, so this would be just simply a fraction. How could we convert this fraction to a regular fraction? So this decimal fraction, how can we convert it to a regular fraction? Now you will follow what we just did a while ago. Anybody would like to walk me through this? Let me call on someone. Miss Trivia, would you like to walk us through this? Miss Trivia, are you there?
I'm sorry, sir.
All right, go ahead and try, Miss Trivia. Tell us what to do.
So, 43, we would have 3. So what are we doing first and foremost before
We're
we begin?
converting this decimal fraction to a regular fraction.
To a regular fraction?
Yes.
Okay. So like so we do, at the beginning we have a 0 before the decimal as the whole number. So over the other side, no, we would have. Hold on, I'm trying to work it out.
All right, what I'll do, I'll give you guys about 5 minutes to work out this and I'll check back with you and ask you what you get. All right, go ahead and do that now for me, please. All right, did anybody get the answer to it yet? Miss,
Sir, I have 305 over 1,000.
okay, but did you simplify it? Miss Waysome, did you get the answer?
Same, sir, but I didn't simplify it as yet.
Okay. All right, so everybody should at least gotten the fraction. So if you have 3 digits after the points, it means that in your denominator, you're going to have 1 with 3 digits. That means you are over 1,000. So now you put all of those digits, which is 3, 0, 5 over 1,000. So all you need to do now is to cancel down using the highest number you can find that can go into 2 numbers. All right, so obviously you can use 5. So 5 into 300 give you what? What you get in the numerator, students?
61, sir.
61. And in the denominator, you will get what? 5 into
200.
200. Can this be simplified any further? Can you find any number that can divide both 261 to cancel it down?
No, sir.
No.
No, sir.
So that means that's
Oh, sir.
the simplest form of the fraction. All right, so that would be the answer if you convert this to a regular fraction. Is everybody clear on that now? Is that clear, Miss Green?
Yes, sir. I was just wondering what she used to divide, but I figured it out.
Okay. Mr. Reed, are you following so far?
Yes, sir.
And you're understanding what we have just done, right?
Yes, sir.
All right, good. All right, so continuing down on this decimal road, what we want to do now is to look at addition and subtraction of decimals. All right, now we know that in adding and subtracting decimal, you have some rules that we need to follow. So if you're adding and subtracting decimal, we generally add them in the same way like how we add whole numbers, except we need to place the decimal points in vertical columns beneath each other when we're adding. So we first line up the points under the points, and wherever the numbers fall, like for instance, this number, we would write them in a column form, point under point. Now, what you notice here, where you have a whole number 12, it would come before the points. So you put down 12 and you put a point, but where you have this empty space after the 12, in order to hold our position, our place values, we fill in the empty space with the place values, our placeholders of zeros. So for the first number, which is 0.539, we see that that has 3 digits that come after the point. The second number, which is 9.65, has 2 digits that come after the point. So to make a uniform place value, the ones that are missing, we add zeros to fill them in. So here we would add a 0 for this one, which this 0 here is a 0 that was added. And for this, we put a point because a whole number. So the decimal part that comes after would have 3 zeros for your place values. And then now, once we line them up where we have points under points, so the point must be in a vertical column, one beneath the other. So once you line them up like that, then you add now in the usual way that you would add whole numbers. All right, so to do this, we simply add 0 plus 9. Down here we would get what? We would get 9. And if we add 0 plus 5 plus 3, down here we would get what? 8. And if we have 6 plus 5, we get 11. So we would put down 1.
And carry the 1.
1. So we have, but remember now, this point here now, the one that we carry is a whole number. So we'd have to put back a point here. So we'd have 1 plus 9, give it 10 plus 2, give it 12. So you put down 2 and carry 1. And so this becomes 22.18. All right, guys. Hoping that you are following. Everybody see how we get that so far? Any question?
Yes, sir.
All right. Very good. All right. Now, any question for the others? Everybody following? Let me find out Mr. Miss Miss Cummings, are you okay? Miss Scott? Are you okay?
Yes, sir. I'm okay.
Yes, sir.
Okay. And Mr. Javon, are you okay? Xavier, are you okay? All right.
Yes, sir.
So that is a simple rule that we have to follow when we're adding decimals. And if we are subtracting, we still need to put the points under points, right? But you know, for subtraction, you can only subtract one number from the other. All right, moving along. Here, we are now going to be looking at how to multiply and divide by decimals, or how to multiply and divide decimals. All right, so here we have rules too as well. Now, let us look at one of the advantages of decimal. So we say one of the advantages of decimal is the ease with which they may be multiplied or divided by powers of 10. Now, when we say powers of 10, we mean like 10 times 10 would give you 10 to the power 2. That means you will get 10 times 10 give you 100. And times 10 again, you will get 1,000.